Welcome back. We continue to give more examples on integration by substitution method. So I have an appetizer to evaluate the integral 3x squared sine of x cubed dx. So solution to this, remember the trick on integration by substitution method is to identify the correct part to fix into the integrand so that your integration process is simplified. So there is 3x squared and there is x power 3. So the best part to choose as u is a part that when you differentiate, the result that you get will cancel with some parts involving the variable in the integrand, or after integration, you'll not have that variable that was initially in the integrand. And a keen observation on this integrand shows you that this 3x squared is the derivative of x power 3. So therefore, this would be the best choice for u. And you say, let u to be x power 3, which means the u is the same as 3x squared dx. So this integrand, 3x squared sine of x cubed dx, you see it can be written as sine, because I've already fixed this one, sine u times 3x squared dx. Or let me just keep so x power 3. This is the same as this one here. And so this part we replace by du, and this part we replace by u. So that integral 3x squared sine x cubed dx will be the integral. Now sine of u, because this part is u, all this is definition of the u. And from our other discussion, integral of a sine function is a cos function. Then we add a constant of integration. So therefore, integral of 3x squared sine x cubed dx is cosine of x cubed plus c, because u is x power 3 from our process. So this will be the solution. And then the second problem, B, integrate so remember the integral of sine is negative, not this a negative sign, negative sine cosine of u. Please note that integration of a sine function is a negative cos function, and integration of a cos function is a positive sine function. So that should be clear. So there's a negative sign here. And then the next problem, integral of x into brackets x squared plus 9 power 5 dx. So this second problem, we see that what is inside the bracket, if we differentiate it, we get an x. So that would be the best choice for you, so that the x we get in the derivative will cancel with this other x here. So let u let u be x squared plus 9. So which means du will be 2x dx, which means dx alone will be du over 2x. So this you write it as integral of x times u power 5, where there is dx, you put du over 2x. And I hope now you can see that this x and x cancels out, so that we'll have the integral u power 5 du over 2. Then you factor out 1 over 2, integral of u du, then u power 5. So that will give us a half times u power 5 plus 1, which is 6, then plus c. So this will be 1 over 12 u power 6, then plus c. So if you bring in back the original value of u, so we say therefore the integral of x into brackets x squared plus 9 raised power 5 dx is 1 over 12 into brackets u is x squared plus 9 raised power 6 and then plus c. That's what we'll have. Our next problem C. Integral of x squared plus 2x divided by x power 3 plus 3x squared plus 12 raised power 6 and then dx. Now, what we do in this integral, we fix the bracket in the denominator. So solution. So let u to be x power 3 plus 3x squared plus 12. So let's fix this bracket. And we are fixing that one because you see this has highest power 3, this highest power 2. So when you differentiate this polynomial of highest power 3, you expect to get a polynomial of degree 2, which we can do factorization to ensure that now we do away with this numerator part. So this implies that du will be, this will be 3x squared plus 6x dx. Derivative of a constant is 0. And you see 3x squared plus 6x is the same thing as saying 3 into x squared plus 2x dx. At least we should be smiling because we can see this factor is the same factor in the numerator. So which this tells us that the x alone, we divide through by this. So we'll have du divided by 3 into x squared plus 2x as a solution. Now, so therefore, this integral will be integral of x squared plus 2x. Now divided by, remember we fixed the bracket in the denominator as u, so it'll be u power 6 times du divided by 3 into x squared plus 2x. And so by that fixing, we see that this bracket and this bracket cancels out. So we'll have integral 1 over u power 6 times du over 3. At least now the integral we have is easier to evaluate by power rule. So the next step will be this equals to factor out the third, and then u 1 over u power 6 can be written as u raised power minus 6. Those are loss of indices. So this is a third integral. Now u power minus 6 du. So using power rule, this would be 1 over 3 times u raised power minus 6 plus 1 over minus 6 plus 1 plus constant of integration c. Minus 6 plus 1 is minus 5 times 3 is minus 15. So this is the same as minus 1 over 15 u raised power minus 5 then plus c. So therefore, the given integral, you don't leave your answer in terms of u. So therefore, the integral of x squared plus 2x dx over x power 3 plus 3x squared plus 12 raised power 6 is minus 1 over 15 into x cubed plus 3x squared plus 12 raised power minus 5 and then plus c. So that's how we solve that problem. So this is the final answer. Next part, C, integral of sine of 7 theta plus 5 d theta. Now what we do for this, we fix the bracket. So solution, let u to be 7 theta plus 5, which implies du is 7 d theta, which means when you make d theta the subject, will be du divided by 7. And then so integral sine of 7 theta plus 5 d theta will be the same as the integral sine of u, we have fixed this to be u, times du over 7. So du over 7. So factor out there 1 over 7. So I'll have 1 over 7 integral sine of u du. And when you integrate sine function, you get positive cos function. And when you integrate sine function, you get negative sine function, cos function, and then u plus c. Remember, we have explained here that integration of sine function, is negative cos, and integration of cos function is positive sine. So that will give us minus 1 over 7 cos of u d plus c. So therefore, the integral of sine of 7 theta plus 5 d theta is minus 1 over 7 cosine of 7 theta plus 5 plus c. So this is the final answer. Second last problem. Integral of e raised power minus 9t dt. So we fix the power. So we say let u to be minus 9t, which means du will be minus 9 dt. So dt alone will be negative du over 9, simply divided through by minus 9. So the integral of e raised power minus 9t dt will be the integral e raised power u times minus du over 9. So we factor out negative 1 over 9, integral e raised power u du. And whenever you integrate an exponential function, you get exponential function. So that would be negative 1 over 9 e raised power u plus c. So the given integral, therefore, integral of e raised power minus 9 t dt is negative 1 over 9 e raised power negative 9 t and then plus c. That's what we have. We'll give more examples in the next session. Thank you.